Hi, do you know how to write the electronic configuration for the following ions? No? No worries, join my class. Hi everyone, welcome to my channel. Today we're going to have a new video talking about the electronic configuration for simple ions, and we're going to define what we mean by cations and anions. Don't forget to answer the questions at the end of the video. Put your answer in the comment section, and also if you have any question, please share it with me in the comment section. Thank you. Ion is an atom or a group of atoms that lost or gained electrons. Since our lesson is about simple ions, so we're going to talk about atoms when they gain or lose electrons. Let's start with sodium atom with atomic number 11. Since it has atomic number 11, it means that it has 11 protons and 11 electrons. I drew the protons with a blue color, the electrons with a green color, and the neutrons with a red color. Don't forget that protons are positively charged particles while electrons are negatively charged particles. And since here we have 11 protons and 11 electrons, it means that the positive particles are equal in number to the negative particles. And as you noticed, sodium, it has one electron in its outer energy shell. For sodium to apply octet rule, it needs to lose that electron. If you want to learn more about octet rule, I will keep a link in the description for a video describing what do we mean by the octet rule and what do we mean by valence electrons. So when sodium loses one electron, now it will have 11 protons and 10 electrons. So now the positive particles are more than the negative particles by 1. So the charge of the sodium is going to be +1. And if we want to write the electronic configuration for sodium, it's going to be as follows. Don't forget, if you want to learn more about how to write the electronic configuration, you're going to find a link in the description showing you how to write the electronic configuration for different atoms. And as you noticed, the electronic configuration for sodium ion is different than sodium atom, since sodium lost one electron and now it has 10 electrons instead of 11. Let's have another example about fluorine. Fluorine with atomic number 9, it has 9 electrons and 9 protons. And since the electrons are equal to the protons, so the positive particles are equal in number to the negative particles, and it doesn't have any charge. For fluorine to apply the octet rule, it needs to gain one more electron. So now it will have 10 electrons with 9 protons. So now the electrons are more than the protons by 1, and the charge of the fluorine is going to be -1. And if I want to write the electronic configuration for fluorine ion, it's going to be 1s2, 2s2, 2p6 with 10 electrons, not 9 as fluorine atom. So as you notice that when the number of protons is more than the number of the electrons, the charge is going to be positive and then the ion is going to be cation. But when the number of the protons is less than the number of the electrons, the ion is going to be negative, and then we are going to call it anion. So from now on, positively charged ions, we're going to call them cations, while negatively charged ions, we're going to call them anions. Let's start practicing by writing the electronic configuration for different ions. The first, we're going to start by writing the electronic configuration for aluminum ion with a charge 3+. 3+, it means that it lost 3 electrons. So now we're not going to write the electronic configuration for 13 electrons. Instead, we're going to write the electronic configuration for 10 as follows: 1s2, 2s2, 2p6. Another example, selenium ion with atomic number 34 and a charge -2. -2, it means that it gained 2 electrons. So now we're going to write the electronic configuration for 36 electrons instead of 34. And it's going to be as follows. As I told you, there are going to be a link in the description for a video about how to write the electronic configuration. As we can see that if we add the number of electrons in all the suborbitals, we're going to have 36 electrons instead of 34. So at the end, let me summarize what we have learned. When we have positive ions, it means that electrons are being lost, and you have to deduct that number from the atomic number before writing the electronic configuration. While when the ion is negatively charged, it means that electrons are being gained, and then you have to add that number to the atomic number before writing the electronic configuration. So positive you deduct, negative you add. Now it's your turn to answer. Pause the video, copy the questions, answer them, put your answer in the comment section below. Thank you.